Hi everyone, my name is Satya. In this video, we are going to talk about AlgoDEA. What is AlgoDEA? AlgoDEA is a IntelliJ plugin for Algorand Blockchain. It provides end-to-end development lifecycle on Algorand Blockchain using IntelliJ IDE. Using this plugin, developers can create, test both stateless and stateful smart contracts directly from their IntelliJ IDE. It also provides other features like ASA management, Algorand standard asset management, transactions, test account management, and many other features supported by Algorand Blockchain. This plugin is currently supported in IntelliJ IDE Community Edition, Ultimate Edition, and Education Edition. These are some of the useful links specific to AlgoDEA. Documentation for this plugin is available at algodea-docs.blockspin.com. This plugin is also available in JetBrains official marketplace, so you can directly install this plugin inside your IntelliJ IDE. Before jumping into the demo, let's talk a little bit about Algorand Blockchain. Algorand is a public blockchain and protocol that aims to deliver decentralization, scale, and security for all participants. Its native currency is Algo. It uses a permissionless proof-of-stake protocol, which is called pure proof-of-stake. And Algorand is the first blockchain to provide immediate transaction finality. Let's go through different features supported in Algorand. I'll just highlight some of the key features which we will be covering during this demo. Similar to other blockchain like Ethereum, Algorand also supports smart contract. There are two kinds of smart contracts supported in Algorand: stateless smart contract and stateful smart contract. Algorand smart contracts are small programs written in an assembly-like language, and this language is called PyTEAL, or Transaction Execution Approval Language. Stateless smart contracts are used to approve or deny transactions, and these are evaluated at the time a transaction is submitted. No long-term state is associated with the contract. So in stateless smart contract, you cannot maintain state. PyTEAL programs have one primary function in this case, and that is to return true or false, and are used to analyze and approve transactions. Usually standard transactions are signed with either a private key or multi-sig set of private keys. With stateless smart contract, they can now be signed with a PyTEAL program, and this is called a logic signature or logic sig. Stateless smart contract has two basic usage scenarios. It can be used as a contract account, or it can be used as a delegated signature. Let's talk about contract account usage mode. When PyTEAL code is compiled, it returns a Algorand address. The contract account address can be sent algos or any other Algorand assets from any account using standard transaction. But when sending from a contract account, the logic in the PyTEAL program determines if the transaction is approved or rejected. The next usage mode for stateless smart contract is delegated signature. So in this mode, you can sign a PyTEAL program with a private key or multi-sig keys and save this as logic signature. Now you can give this logic signature to someone else to submit transactions with your authority. The PyTEAL program can limit the amount of authority you delegate. For example, you can create a delegated signature that allows a billing company to remove up to X algo from your account every 50,000 blocks. Algorand also supports stateful smart contract. Stateful smart contracts are also written in PyTEAL. These are contracts that live on chain and are used to keep track of some form of global or local state for the contract. Stateful smart contracts are called through special Algorand transactions that are processed by the contract score. Some of the transaction types supported in stateful contracts are creation, update, opt-in, deletion, closeout, clear, and standard call transactions. Stateful smart contracts are similar to smart contracts supported in other blockchains like Ethereum. The Algorand protocol supports the creation of on-chain assets that benefits from same security, compatibility, speed, and ease of use as the algo. The official name of assets on Algorand is Algorand Standard Assets. With Algorand Standard Assets, you can represent both fungible and non-fungible assets. You can think about Algorand assets similar to ERC20 tokens without any code. Atomic transfers are batch transactions that allow groups of transactions to be submitted at one time. If any of the transactions fail, then all the transaction will fail. So some of the use cases are circular trades, group payment, decentralized exchange, etc., etc. Now, before jumping into the demo, now let's see what are the different things we'll be covering in this demo. First thing we'll cover node configuration. We'll see how you can configure a new Algorand node inside your IntelliJ IDE. Account management. We'll see how you can create an account, how you can top up an account, and how you can use the created account to do some transactions. We'll go through payment transaction. We'll create a stateless contract, and you will try to use that contract in a transaction. We'll create a stateful contract and try to create different type of transaction for the stateful contract. We'll go through asset management, atomic transfer, and finally we'll see how to export a transaction and how to use dry run feature supported by AlgoDEA. Okay, let's start the demo. So I've opened my IDE here. So I can now go to plugins. I have already installed AlgoDEA plugin in my IDE. So the installed version of AlgoDEA plugin here is 0.2.0. So let's first create a project. Now you can see there is a new option here, Algorand Smart Contract. Let's select this. I'm not going to select stateful contract for now. Let's call our first project as first contract. Okay, now that our project is created, let's go to the folder structure. So if you see here, there's a source folder. Under source folder, there's a main folder, and under main, there's a TEAL folder. And we're going to create our TEAL files under this TEAL folder. And if you notice here, there is a algo-package.json file. This is like a project configuration file here in this case. Every algo project in IntelliJ should have this file. And if this file is there, then Algorand specific behavior will be enabled by the plugin. If you are importing your own project, you have to just make sure you create this file manually. And source folder structure doesn't matter as long as you can define a source root inside your project. You should be good. So in algo-package.json file, you can see there is a empty array stateful underscore contracts. It's basically whenever you create a new stateful contract in the project, the definition will go inside this array. But right now we don't have any stateful contract in our project, that's why it's empty. So the next step we are going to do, we'll configure a new Algorand node inside our IntelliJ IDE. You can configure a pure stack node, you can configure your local custom Algorand node, or you can also configure a node based on sandbox. Let's try to configure a new node inside our IDE. So you can see there is a tab Algorand Explorer here. You can click on the tab, and now you can see there are two kinds of configuration here: local SDKs and nodes. So local SDKs are basically configuration which will point to a local Algorand folder. This is useful when you try to compile your TEAL program using goal binaries. So if you want to compile your TEAL file, both stateless and stateful contracts using a goal binary, you can configure a local SDK. But if you see the second configuration option like nodes, these are these are the configuration which will point to a running Algorand instance. It could you can deploy or install a local Algorand node in your local server or on a remote server, or you can also point to a pure stack.io node. So let me configure my local Algorand node here. So I already have a pure stack node configured here, but let me add a new node. So I can click here or I can also right click and do add Algorand node. So I need to provide few basic information here. So let me call my server edge my Algorand node, and I need to provide a AlgoDEA API endpoint. So let me get my API token, API endpoint URL. Okay, I need API key, which I'll be getting from my Algorand node installation folder. Okay, I copied this API token from my Algorand installation folder, and if you're pointing to your own Algorand node, you don't need to provide indexer API endpoint. But if you are configuring a pure stake.io node, both AlgoDEA API endpoint and indexer API endpoint are mandatory. So now you can do fetch network info. Okay, I did something wrong here. Okay, this should be dot. Okay, fetch network info. Then okay, so my local Algorand node is basically a testnet node. Now I can do okay. Now I can see my Algorand node here. Now next step I can basically do, I can right click here and I can say, okay, use this node for compilation. And again, if I right click again, use this node also for deployment, right? What you can also choose a particular node only for compilation. Like if you select this local SDK and right click, local SDK, you can only select for compilation. You can select local SDK for compilation, and you can select your custom Algorand node for deployment. That's also possible. But in this case, let's select my Algorand node for both compilation and deployment. So our node is now configured. There is an alternate way to do the same stuff. Let's say you right click here, go to Algorand and go to configuration, and the same thing you can do here. You can see here my Algorand node is selected for both compilation and deployment here. Okay, the next thing is we're going to see is account management. To interact or to post any transaction to Algorand network, we need an account, and we need some algo in that account because we need to pay some fees for every transaction submission, right? But account management in a test environment sometimes becomes very painful because you need to keep private key and address for this account somewhere in a text file or in a machine, and every time you need that account, you need to copy paste those private key or mnemonics. So let's see how AlgoDEA plugin solves this issue. So to create an account, you right click here, go to Algorand, go to accounts, and you can create a new account directly from here, or you can select list accounts. In the list account UI, you can then select new. Let's call my first account as Alice. So my first account is there. The name is Alice. Let's create a second account. Let's call it Bob. And let's create one more account, and let's call it Sam. So now we have 3 accounts there. One thing to note here is you can also import an existing account. You can provide mnemonic here and give an account name. The account will be imported. Also, you can import an account as read-only account. That means you don't want to submit any transaction from this account. You just want to check balances or some other thing for that account. That's also possible. In that case, you just need to provide the account address here and provide a name and click OK. One of the example could be contract account address, where you want to just check the balance of a contract account. Okay, so let's try to do fetch balance for our accounts. Okay, now if you see, the balance is basically 0 for all 3 accounts. Now we have account now. We need some testnet algo tokens here in our account. So to do that, open your browser, search for Algorand testnet faucet, and the very first search result is Algorand dispenser. You can click here. Let's go back to our account user interface, right click here and do copy address. Now you can paste this address here, select I am not Robert. Let's select all. Okay, now click dispense. Okay, so transaction has been posted successfully. So now go back to our ID. Next, to fetch balance again. Okay, now you can see we have 100 algos in Alice account, right? So now let's do a payment transaction. We'll transfer some algos from Alice account to Bob's account. So to do a payment transaction or transfer transaction, you can right click, go to algo, go to transfer, and we have our transfer user interface here. So first thing you have to do, you have to select a from account. In this case, our from account is Alice. And you can see the available balance here, asset type algo. Now you have to select to account. So let's select to account as Bob. And let's put amount as 20 algo. Before submitting the transaction, let's check one more thing. If you click on the tab transaction details, you can provide additional info inside this additional detail for this transaction. You can provide a note here for our transaction. Let's put it as hello, and you can put first valid, last valid, but for now let's keep this blank. Okay, let's go back to transaction details and let's try to post our transaction. The transaction has been submitted to the network now. You can see it's using my local Algorand server to send the transaction, and transaction is now successfully executed. So now you can see a link here which is pointing to transaction detail. If you click here, it will take you to Algo Explorer. And now in Algo Explorer, you can see we have successfully transferred 20 algo from a sender account to receiver account. And we also provided a note in our transaction. So now if you see here, this is actually base 64 version of hello. So if I do, okay, if I enter that value, now if I decode, okay, this is hello. So this is how you can do a payment transaction in IntelliJ. And now you right click, go to Algorand. Let's go and check our balances. So if I do fetch balance, now you can see Alice has around 80 algo and Bob has 20 algo. So similar to normal account, you can also create multi-sig account. If you do create multi-sig account here, you can create a multi-sig account in your IntelliJ ID. So in case of multi-sig account, you have to select a threshold first. Let's select threshold as 2 in this case, and let's select our account. We have 3 accounts. Let's select all 3 accounts. Okay, so we selected all 3 accounts here. You can also provide an external account. You can just provide a mnemonic here and click add. So let's press OK to create our first multi-sig account. Okay, our multi-sig account is now created. This is the address, and these are 3 accounts, part of this multi-sig account with threshold 2. Now, if you right click, go to Algorand accounts list multi-sig account, you can see all our multi-sig accounts here, and you can see the details. If you do fetch balance, of course, the balance is 0. The account created in IntelliJ ID are not specific to any project. So you can use this account, or you can use this node configuration in any project. These configurations are basically global. Okay, one more thing I want to show. If you right click and go to account, list accounts again, um, uh, you right click on a particular account, you can see there is an option show details. So if you click on show details, it actually shows the account details here. So the balance is here, account name. You can also update the account name here, and you can see there are fields for created apps, created assets, and opt-in assets for this account. But in our case, we have not created any apps or assets using this account so far. So these values are basically empty for now. We'll come back to this UI later. One more thing to note here is the account we created now are created locally in our machine, and these are stored in a file system in an encrypted form. If you want to know where these accounts are stored, you can go to your home folder and you can do cd AlgoDEA, and inside AlgoDEA folder you can see there are two files, .algorandaccount.conf, .algorandaccount.conf.key. So, and if you do cat dot algorandaccount.conf, you can see this binary file basically has a list of all the accounts, and they are mnemonic. And the key is basically contains our symmetric key. Okay, so this is our secret key. Okay, so now our account management is done. Now let's try to create a PyTEAL file, or let's create a stateless contract first. So to create a stateless contract or a PyTEAL file, you can right click here and select new, select PyTEAL file. Okay, now you can see there are many templates available here. These are all stateless contract template. Let's select one of the template, dynamic fee. So let's call our PyTEAL file as dynamic fee. Okay, so if you see here, the ID automatically generated a PyTEAL file for us, and to compile this PyTEAL file, now we can right click and do compile PyTEAL. One thing you can notice, it's actually asking to provide some values, right? Let me explain why. So if you see in the PyTEAL file, we have some placeholder here, which are like var underscore template, tmpl underscore 2, var underscore tmpl underscore cls, and there are a few other placeholders here. So if you want to keep a placeholder inside your PyTEAL file or inside your stateless or stateful contracts, you can do so by doing var underscore tmpl underscore the placeholder name. So whenever you try to compile your PyTEAL file, it will automatically detect that, and then it will ask for the input during compilation. Let me highlight few editor level features here. So in this PyTEAL file, if you do control space, you'll get autocomplete feature here, right? You'll get list of all the opcodes supported in PyTEAL. So then you can do, let's say, transaction here. So once the opcode is selected, then again, if you do control space, it in this case, it's showing me list of parameter applicable for TXN. So let me select approval program here. So similarly, if I select group transaction of code and select, do a control space, it's showing me two parameters here. Let's select this. Let me provide the first parameter 0, and if I do control space again, it's only showing me all the options available for second parameter. So autocomplete here is basically context specific, right? Similarly, if you select global, and it will give you all the global fields. Okay, the next thing I want to highlight, you hover on this opcode, you can see a help dialog here. So, and then you can also see there is a link to official talk. If you click on the official talk, it will take to the official talk for that particular opcode. Now you can see GTXN or group TX transaction opcode specific help here. Now to compile this TEAL file, again you can do right click, compile TEAL, and then you can provide the placeholder here, right? If you don't have any placeholder, this dialog will not be shown. But for now, let's just put one. I think the compilation will fail, but I want to show something else. So click OK. Go here, the compilation failed, right? But let's try it again to compile TEAL. Now you notice that the previously entered informations are already there. So what ID does, ID is basically caching all this information, input information. So you don't need to enter this value again and again. Now that we know what kind of editor level features supported for our TEAL file, let's delete this file and let's create our first stateless contract. Let's create a stateless contract. Let's call it sample contract. So I'm going to copy paste some code. This is a very simple contract, stateless contract. If you see here, we are getting receiver field from the transaction, and then we're checking if the receiver field is equal to this address, and then in line 7 we're getting amount, and in line 8 and 9 we're basically checking if amount is less than equal to 10 algos. If both are successful, then this transaction will be approved. So now instead of hard coding this account address, let's put a placeholder here, right? Let's call it var_tmpl. As we know, all our placeholders should start with var_tmpl, and let's call this placeholder as receiver, right? So now we need to compile this stateless contract file. So, but before that, let's copy an account address, because during compilation we'll be asked to enter the value for this placeholder. We can go to accounts, and then we can go to list accounts. Let's select Bob's account now, and right click, and you can do copy address. Now let's try to compile this stateless contract. We can right click here, you can say compile TEAL. So it's asking us to enter an address. So I can just do paste here. This is Bob's address, and I can do OK. Our TEAL file is now compiled successfully. Right now, you can see now there is a new folder, generated source, because we have some placeholder here in our TEAL file. That's why the ID basically created the final TEAL file here with the actual value for the receiver address, right? This is our old contract. I can just safely delete it now. Okay, so our final TEAL file is generated here. But if you also expand this build folder, you can see there is a talks folder, and there is a file called sample_teal.talk. So this is our compiled file for our stateless smart contract, right? So now that we know how to compile our stateless smart contract, let's try to create a logic_sig file. So what we are going to do in this file, basically, we can sign this TEAL file with an account, and we can then give that logic_sig file to someone else, so that he or she can then submit a transaction. You can right click, you can select stateless contract and select logic_sig. Now this is our account for this placeholder. You select OK. And now you need to select type of what is the mode for your stateless contract, right? In this case, let's select delegated signature, and the signing account, let's select Alice, right? To OK, because so we don't have any args in this used in this TEAL file, so I can just click OK. Okay, now you can see our logic.sig file is generated successfully. So if you see here under build folder, there is a lsig folder. Lsig stand for logic.sig. Under lsig folder, we have a sample.lsig file, and we have a metadata file here, sample metadata JSON file, which keeps track of some metadata information which are used in the plugin. Okay, now we can select this sample.lsig file. This is a logic.sig file, and let's say we want to create a payment transaction, and we'll sign our payment transaction with this logic.sig file. This is logic.sig dialog or user interface. If you see here, ID automatically detects that this file is a delegated signature logic.sig file. The sender information is automatically populated. Now let's select the receiver. Now let's select the receiver as Sam's account. If you remember, we have given the address as Bob's account. I think this transaction will fail, but let's see. So let's enter amount as 2 algo and do OK. Okay, if you notice here, actually our transaction is failed. So basically the transaction was rejected by logic, because if you see here, let me open the generated source. If you see here, the address in the TEAL file, the receiver address in the TEAL file is different than this is receiver address, right? Let's try to send the transaction again. Right click, select send transaction. Now in this case, we'll select Bob's account, which is the correct address, right? And let's transfer 3 algo to Bob's account. Our transaction is now successfully submitted to the network. Let's wait for some time. Okay, so now it's successful. Now if I click here, I can see 3 algo transfer successfully from Alice's account to Bob's account. And you can also see the source code for the TEAL. So now let's go back to the ID. And if you right click, select accounts again, go to list accounts and do fetch balance. You can see Alice has 76.99 algo and Bob has 23 algo. This is how we need to create a stateless contract, and we can also create a logic.sig file, and then we can use that logic.sig file to do any transaction. Okay, so the next thing we're going to see is a stateful contract. For stateful contract, let's create a new project. Let's select new project, and in this case, we can select stateful contract here, right? And let's call it first stateful contract, right? Now, if you see our approval program and clear program file names are there, you can change it if you want, but in this case, let's keep it to the default value. Then you can click next, and we can call this is our first stateful contract project. Click finish. Okay, so you can see the directory structure is exactly same, but if you expand, you can see there are 2 TEAL files generated here, one for approval program, one for clear program. And if you see here, this is a simple stateful contract. This is a default contract generated by the ID. This is basically a counter contract. If you see what we are doing here, we are maintaining a field counter, global state counter, and every time you call this contract, the counter value will be increased by 1, and then we are putting this value, or you are storing this global value here. Okay, I want to show one more thing here. If you go to algo package.json now, Now you can see we have our contract definition here for our first contract, right? Let's close it. Okay, so now you can have multiple contracts, stateful contracts in a project. To do so, you can create a TEAL files here, and once it is created, you can right click and you can go to Algorand configuration, and you could go to contract settings. Here you can see the list of contracts, stateful contracts in our project. You can do a new contract, you can provide the contract name, and similarly you can select contract approval program, clear state program, and then okay, then the contract definition will be added to the algo package.json file here. But for now, let's just go ahead with this single contract, stateful contract now. Okay, so our stateful contract is now ready to be deployed. So what we can do, we can again right click here. We can say Algorand. We need to select stateful contract. You can see there are many options here, right? These are different type of transactions supported by stateful contract. So the first thing we need to do is to select create app. Okay, this is a new app and there is no Algorand node configure for this project, right? So we can select configuration and select okay. I'll use my Algorand node for configuration compilation, and I'll select for deployment. I'll select the same node. Then click OK. Now let's try again. So now you can see there is a user interface for create app, stateful smart contract. We need to provide a creator account. Let's select creator account as Alice account, and mnemonic is all automatically copied here, and our contract name is first SF contract, and these are the details. If you remember, this is a counter contract, and we are basically maintaining one counter in global state. So we need one global int here. So let's make it one and do OK. Before submitting the transaction, let's see these tabs. So if you click on app transaction details, there are some other options available here. You can provide arguments, or you can provide accounts. But for now, let's keep those empty. And the third tab is basically transaction details. These are like generic transaction details. Let's go back to app details and click OK. So the create app transaction for our stateful contract is now been submitted to the network, and now the transaction is successful. Now if I click on this link in Algo Explorer, now we can see the transaction is successful and the transaction type was application call, right? So our app is now created, stateful contract is now created. So the next step is we'll try to make a standard call to this stateful contract, right? To do that, we right click here, and we can go to stateful contract, and we can select call. And now here you can see there is a app ID drop down. You can select the ID here. This is our last deployed contract. If you have multiple IDs here, and if you just want to select the last deployed application ID, you can just select here last deployed ID. And in this case also we have to select a from account, right? And then we can do OK. This is now sending a call or no up transaction to the same contract that we deployed before. You can see the status of the transaction here in the link also. Now if you notice here, the value of our counter now increased to 2, right? There is another way also. You can read the global state or local state. You can right click here, go to Algorand, again go to stateful contract. If you do read state, you can select global state here and then select the app ID or select the last deployed app ID and do OK. And you can see the counter value is 2. Let's do one more transaction and our counter value should be increased to 3 then, right? Let's select call again, select same contract and select Alice account, click OK. Okay, the transaction is successful now, and if you see the value is 3. Okay, and similarly, if you go here, go to stateful contract to read state and do OK, the counter value is now 3, right? And if you go to stateful contract menu item, you can see there are other options available here, like you can do a opt-in transaction, you can delete a contract, you can update a contract, you can do a closeout, clear state transaction. So this is stateful contract, and this is how you can use IntelliJ to interact with stateful contract. Now let's see how the asset management feature is supported in IntelliJ IDE. So we'll try to create a new asset, and to do that, we can right click. You can do Algorand, then you can select assets and to create assets. So this is the user interface for creating or managing any Algorand standard assets. So for our assets, let's call it XYZ token, right? Let's call it like XYZ. XYZ token, and let's put the total supply hedge 200 million. I hope I'm correct. Okay, and decimal, let's keep it 0. You can provide an asset URL, provide a HTTP URL here. You can provide some metadata hash here. Both string and base64 values are supported here. And we need to provide a manager address for this asset. Let's assign Bob's address as manager in this case. Let's put a reserve address also in here. So let's put Sam's address as reserve address. And let's keep freeze address and clawback address blank for now. Right? We need to provide a creator address. So creator address could be anything, but let's use Bob's address in this case also. Okay, so now you can provide other transaction detail information here, but let's not do it. Let's just post this transaction to create this asset called XYZ. So the transaction is now being submitted to the network. Okay, so our asset creation transaction is now successful. You can see the details about our created asset here. Okay, so this is our newly created asset with a supply of 200 million XYZ token. Manager of this asset is basically Bob. So I think if we go now to Algorand accounts, list account, and select Bob's account and select show details, now you can see Bob has like 200 million XYZ, right? Now if Bob wants to transfer some XYZ to Alice, so Alice has to first opt in to this asset, and then only Bob can transfer. So let's do that. So the next thing we'll see a opt-in transaction for our asset. So we'll go to Algorand, select asset, and select opt-in. And in this case, we'll select XYZ asset and do search. Okay, this is the detail of our asset with 200 million supply. And now let's select Alice as transaction sender and select opt-in. So now our opt-in transaction is now successful. Now if I again right click, go to accounts, go to list account, select Alice, select show details. Now you can see Alice has already opted into this asset, but Alice has zero balance, right? So now let's try to transfer some XYG token from Bob's account to Alice's account. So you can select the same transfer option here. And in this case, let's select Bob's account as sender account. And we need to select Algorand standard asset here as asset type. And then you can do fetch assets. Now we need to select Alice account and let's transfer 1000 XYG token to Alice account. Then you can do OK. So now if you see here, we're transferring Bob's account to Alice account, 1000 XYG. So our asset transfer is now successful. If we click here, you can see the transaction detail in Algo Explorer. We transfer 1000 XYG token. And if you go to Algorand accounts, list accounts, right click, show details, you can see we have 1000 XYG token in Alice account. Okay. So that's how you can transfer assets from one account to another. Let's see one more thing before you move to next segment. We can also modify an existing asset, right? And the modification can only be done by a manager address. So let's try to modify the asset we created before, right? Let's select XYZ search. Let's remove this reserve address, right? We'll keep it blank. If you notice, the transaction sender is already automatically populated, and this is basically our manager address, right? No one else can modify a asset. Now you do OK. Okay, so our asset modification transaction is now successful. If you right click, go to Algorand, go to asset, and if you select again, select XYG, you see it's empty, right? And that's it. So that's asset management in IntelliJ. Okay, so the next thing we're going to see is atomic transfer. So in atomic transfer, you can send a group of transactions in a batch, and if any of the transaction fail, whole group will fail. Let's see how you can do a atomic transfer inside IntelliJ IDE. So to create atomic transfer, we need to first export our transaction to a JSON file so that we can use it during atomic transfer. So to do that, let's create a stateful call first. So let's select call, and we'll be invoking our same stateful contract that we deployed before. And let's select Alice account again here, and instead of clicking OK here, submitting the transaction to the network, what we'll do, we'll export this transaction, right? There are multiple options here, right? You can do export transaction, you can export a signed transaction, but we'll just do export transaction in this case here. So, and we will do stateful contract call, right? And we'll click OK. Once it is done, then you can go to build, and you can now notice there is a TXN folder here, TXNX folder here, and you can see our transaction is now exported to a JSON file, right? Our first transaction is there. Now let's create another transaction, but the second transaction let's create a payment transaction, right? Let's go to transfer, and let's do a payment transaction from Alice account to Bob's account, but in this case, let's select our newly created asset XYZ. Alice wants to send 500 algos back to Bob, right? And instead of posting the transaction to the network, we'll just export this transaction to the JSON file. So this is our asset transfer. So now our asset transfer transaction is here, right? So now let's create an atomic transfer where we'll basically combine these two and send these two transactions as a group. So now we can right click, select Algorand, go to atomic transfer, and now we can select the individual transaction. That's the first one is stateful contract transaction, and the second one is asset transfer. Now the first step we have to do, create group. Now I can see the create group button is disabled. Now the next step we have to do, sign this transaction, right? We have to, you can select a transaction and you can do sign. If you see, the account is already automatically populated here, so we just need to do sign. Second one also similarly, right click sign, and we do sign, and we're done. Now we can just do OK to post this atomic transfer to the network. Okay, so our atomic transfer in this case is successful, right? So if you see here, there is a link to the group details. If you click here, you can see we had like two transactions here in this group, and the first one is 500 XYG token transfer from Alice's account to Bob's account, right? Okay, so this is successful atomic transfer, right? And if you right click and if you go to accounts, list account, and if you see show detail here, okay, Alice has only 500 XYZ token now. Now let's make an unsuccessful transaction, right? Atomic transfer transaction. So we'll try to make a call from Alice account to Sam's account, but Sam has not opted into this asset, so the transaction should fail. And we'll see how both the transaction, the stateful contract transaction and our asset transfer transaction, both will fail. So what we can do now, we can do another, you can create another transfer transaction, and in this case we'll say okay, we'll select Alice again as sender, and Algorand standard asset with, we'll select receiver address as Sam, but Sam has not opted into this asset, so this transaction should fail. And we'll try to send like 200 XYZ token to Sam. So let's call Sam asset, right? Okay, so now what we can do, we can right click, go to atomic transfer again, and let's select the same stateful contract transaction again and go to Sam's transaction here, create group. One thing I want to highlight again here is if you right click here, do show detail, you can actually see the JSON file here. You can see the group information here. Okay, then we have to individually sign this transaction, right click, sign, click sign, and then we can do OK. Okay, now we can notice here our atomic transfer basically failed with the information that asset is missing from this account, which is Sam's account. Okay, so this is how atomic transfer is done, and we also saw how you can export your transaction to a JSON file, right? Okay, now the last section of our demo is dry run. We'll see how you can use dry run feature inside IntelliJ IDE, right? To use dry run feature, we first need to okay, if you right click and go to any of this contract transaction, right? Let's go to a stateful contract transaction. You can see a dry run button here, right? Let's make a stateful contract call. I'll select Alice again, and instead of posting this transaction to the network, let's say I want to do a dry run. I can do dry run, and I need to select the approval source type in this case. You can also, if it's a clear state, maybe you have to select so source type is clear P, but in this case it's approval program. I'll select the approval program and do OK. You can see my dry run result is here. You can see is you can also save the result in a file. So okay, so if you scroll up, you can now see that successful pass. Now, if you go to dry run folder, you can also see the output of dry run. This is useful to debug a stateful contract call or a stateless contract call. You can also use dry run in case of atomic transfer. Let's try to do that. For atomic transfer dry run, you can right click again, go to atomic transfer and select the JSON file. Let's say this stateful smart contract, and do a create group. You can select multiple transactions here, but for demo, I'm just selecting one here. Then you can select sign. You have to do one extra step here. You can go here, right click, select dry run source, and select the source file. If you have multiple transactions, then you have to select dry run source every transaction. Then instead of clicking OK, you can do dry run. And if you're using any additional accounts, a TEAL source, then you can add those here. But for us, we can keep it empty, and then you can click OK. Now I can see the result of our dry run here. Okay, that's how you can use dry run feature to debug your contract calls. Okay, the last thing I want to show is PyTEAL support. In IntelliJ IDE, not only you can create TEAL file, you can also create PyTEAL file, and you also have editor level support to edit PyTEAL file. So let's see how to do that. So in this project, if you right click, you select new, you select PyTEAL file here. Similar to TEAL file, we have also some PyTEAL templates here. Let's select the empty one here and do a sample PyTEAL. So now you can see we have like errors here in red because we have not configured our Python interpreter here, right? You can select configure Python interpreter. This is one time, and it opens up the project setting dialog. You can now select the SDK as Python, and then you can go to this SDK here. We have already selected Python SDK. You select it here again and go to packages section. You can notice I have already installed PyTEAL package here in my local Python installation. But in your case, if you have not installed it, what you can do, click on the plus, and you can search for PyTEAL, and then you can install PyTEAL package here. But for now, we have already PyTEAL installed here, so I'll just do apply and then do OK. So now if you can see here, the errors are gone. And if I do, let's say if I do app, then I can get all my editor level supports here, right? Specific to PyTEAL. So auto completion is working. So now if you to compile this PyTEAL, you can right click and you can say compile PyTEAL, and if you notice here, PyTEAL is converted to TEAL, and then the final TEAL file is now compiled to a .doc file. If you go to folder structure here, you can see in the under generated source, we have our TEAL program, which gets generated from this sample.py, and under build folder we have doc folder. So this sample.TEAL file, you can now you can use this to create a logic sig, or you can also use it inside a stateful contract. the same way as we do for normal .til file. That's it for this demo. Thanks for watching.